Welcome back. This is Beginning C Part 20, Structs, and this time I'm going to continue with discussion about structs. So I left off on structs, and I hope I left you with a good start, and so we're going to go ahead and finish up on structs. So let's get started. So now that we know how to create structs, you can do a lot of different things. And so one of the things that you can do with structs is you can pass them around, okay? And you can pass the structs around to the functions. So for example, let's say we have a function and my sticky mouse. And so let's say we have a function and we call it void and we just want to display the struct display. And we pass it a type person and we have P and we just pass the struct around. And here we can say printf and we display the struct and we say P dot first name percent S and we say P dot first name, and we do the same thing for last name and then for age. And so here we have last name and then we have age, change the type to %E, and we have age, and we just need a way to call it. So what we can do here is say display person, and we have P, we can call it P1, it doesn't matter, variable names don't have to match, and we define a person P, and we can say P equals, and the quick initialization method we can say Mary Jones and age 33, and we go ahead and display the person and we call it, and oh, we got an error. So what does it say? 23 warning, implicit declaration of function display person. So we have something wrong display. Oh, because we only have display. So, and another error. So P1 undeclared first time use. P1, okay, because we didn't call it P1. And so now you can see that I can pass the struct. One of the problems with passing structs in this manner is because you're passing by value. Now, if you remember from earlier discussions, that the address of operator can give us the address of anything. So address, and we can say %n address of P, and we can say in P, right? So we can say address of P, and it's going to give us the address. So we want to do the same thing here, and we want to, before we do it, we want to show the address of P. Okay, we could even show the address of everything else, but there's no need, they're all different. So we can show the address of P, and here we need of P1. Oh, we didn't display our address because we didn't provide the variable 010, and we have X. Let's get rid of the 3%, it's gonna be sharp, and we need the same thing for this one, percent sharp 010X, and that gives us the memory address of P. And as you can see, we have two different addresses. The two different addresses of P, okay, and the function is one, before we call it is another, and so we have two different addresses, which means it's passing by value. Now there's another way to display P if we wanted to pass it, and we can pass it by reference. So let's create another method, display, and let's say we want to display by reference. So we want to display P by reference, and guess what? We got to use pointers. So we can use the pointer, and we can say address of P. Well, this time we don't have to use and P because P is already a pointer, and we pass it that way, except that when you pass by pointer, you have to use pointer notation for structs. This is the way you reference structs when it's pointer, and I don't know why they made this difference in C. It carried on to C++, so it's common in C++ to do it as well. So here we have all the values, and now we are going to go ahead and pass it by reference, and we say display by reference. we have an error. So incompatible type for argument 1, display by reference. Oh, and that is because we have to use the address of operator. And as you can see, the addresses are now the same. Okay, the addresses are now the same, and we have the values there. Now what happens is, now if I change it here, for example, if I was to change here and I change, let's just change the first name, string copy of person name, P first name, and we change it to Bubba, we're going to change it there. And so when it comes back and we want to print the reference, so we say P1 and we say display by reference. Okay, display by reference, and we pass it P1, and then we print F Bubba, and percent, and we say name and percent S, and we pass in P1 dot first name. Okay, and we'll say after, actually we don't want display by reference, we want display the first time around, and then the second time around so we have P1 first name and P1 first name, and we're passing it by reference in one, and we're passing it by name on the other. So name after pass by value, name after pass by reference. Okay, we have an error. Okay, expected before display by reference. Okay, okay, we have an error here. Okay, and we have another error in function expected before token. What did I do? Line 40. Oh. Okay, so what happens when you copy and paste? You copy and paste bad code. So as you can see, now the reference, the values are the same in the case where we pass by reference. So let's put a little bit of a printf here. Put a couple lines in between so we can see it better. So we can see the address here. When we pass by value, they're the same, and then name after pass by value is that. First name Mary Jones Page, name after pass by reference. So and we did not do the string copy on the pass by reference. Let's see what happens when we do that. So we changed the first name, and we have to use the pointer notation. Let's see what happens. When we pass by reference, we can actually change the value stored in P, and sometimes that is a way of copying data over into a struct. You pass the value in and you receive that, and you can modify the data. Like if you wanted to initialize your struct and you want to do that, you can do that. You can also return the struct. Now when you return the struct, you also return by value. So now in this case, if we return the pointer, it's going to return by reference because it's a pointer. So with that said, this is a way to do it. Now what happens if we say, for example, const, and it should give us an error because we shouldn't be able to change it. Ooh. Oh. That's interesting. And that is because P itself, we can't point P to something else, to another struct, but the names, then they still change. So even though we have const here, the strings are not by const, so they can still be changed. We just can't change the values of P. So I don't think we could do, for example, this. We can't say P.age equals 10, and that gives us an error because, oh, not because of that. Let's see if it actually gives us an error. And see, it says we can't read only object. However, you can see that it allows us to change the name because that is itself a reference already. So you can change string variables. So it's something to be careful about. It doesn't guarantee that somebody's not going to change your character types if you pass them in by reference. So it'll prevent something like age and any other primitive type to be changed, but it will not necessarily hold you back from changing the name because that's a character pointer. So let's see what other topics we can get into with structs. Uh, and I think I've covered mostly everything I wanted to cover. Uh, there was one more thing that I haven't covered, and that would include something like this. Let's say, for example, we have another typedef struct, and we have typedef, and we have struct, and we have the typedef struct is address. So let's say we have address, and address has several values. Let's say, for example, we have a char array for street, and we could potentially write a define, and we could say street length. And even if they have the same value, you may still want to consider having separate names because it makes code more maintainable. So in the case of street, we can say street, oh, that's not what I wanted, say street length, and as usual, +1 for the null character. And we could add another one that says, for example, city. And you get the idea. I won't go too far, and I won't even use a define in this case. I'll just say city, let's say nameland, +1. And we got that, and we could actually go further and say char or char state, and we could say 3, right? Because it's 2 plus the null character. So we could say state 3. And what we can have here in person struct, and I misspelled typedef. So what we can have here in struct, we can actually have the person where the person has an address. And the address is, let's just say address. So let's compile this, see if it runs. Okay, it does run. And now we want to display address. So now if we wanted to display the person's address, we'd have to set it first. So let's say, so we have this and this and this. And let's go ahead and display the address. So printf person dot address dot street %s and oh, not that, p dot address street, and we have the street, and we could do the same thing for city. And you get the idea. I won't go much further than that. And we could do the same thing here with the pointer notation. Now it's interesting because the pointer notation is going to be a little bit different, because here we have street.address, so we have street like this, but street itself is not, it's not a pointer, so it's going to be this, and in actuality we have to have p address street. So this, and I didn't change it on these earlier, so for pointer notation. So this will be like this with the arrow notation, and this will be with the dot. So what we say here is this, because we're not accessing the address by pointer, we're accessing the city by pointer. So the address and the city are not, the address itself is not a pointer, the p is a pointer in that city. So there we have that. And let's go ahead and initialize the address. Now for the address, we can also use some nested notation here. So we can have, for example, since we have address, and we have address there in age, and then we can have address, and I believe we can do this. And since we have address, and what do we have for address? Street, city, and state. So let's go ahead, street, city, and we can say Chicago, Illinois. Oh, wait a minute, I left out street, didn't I? So it's street, city, and state. So I left out street. So one way Ave, Chicago, Illinois, and we could do the same thing here, and we could say some street, Austin, Texas, and let's see if it works. Let's give it a try. Oh, wait a minute, what did I do here? This is my printf. I shouldn't do that. I didn't mean to do that. I thought I was declaring, so let's do that. Let's see what happens. And you can see I get my one-way Ave, and it copies the entire struct and two different references. That's a different reference, and even the nested ones. Now, one of the things that I haven't talked about is the fact that when you have a struct, like you do here and here, and you can actually have pointers within your struct. For example, you could have easily said char struct equals state and then eliminate that. There is a danger in that. The danger in that is that if you have that, now your two structs will be pointing to the same thing. So they will be pointing to the same state. So if you change it in one, you will be changing it in the other. And the other thing about this one is that you actually have to allocate memory on your own. So you don't have the advantage of having that, and you don't have the size of the struct. And it's important to have size of structs because a lot of times you need to know the size in its contiguous memory. So you really want to have that. You can have them dynamically allocate memory, and we will get into that once we get into pointers and dynamic memory allocation, but we won't touch that for now. For now, I think I've covered everything I set out to cover, and just play around with them, and you can see how you get address, how you get the values set from the console, how you assign them. This is really the preferred method. I wouldn't go with any other way. I had to show you the other ways because they're there, but I really wouldn't use them, and they're just they can get really messy. The tag not so much, but the anonymous really can get messy. And so there you have it. You have person, you have address, and you have different types. And remember, you can use these here have the scope within here. So you can use the same variable names outside of here, within the same function. And we haven't touched scope, which is something that I should have done a long time ago, but I didn't touch it. I assumed that maybe you got it by now, understanding the scope, but that's really all I have to cover. If you like this video, subscribe so you can get the latest videos coming your way. And also, you can give it a thumbs up. If you have any questions, just remember, comments below. If you want the source code, it's in the description of this video, so just look at the description, click on the description, and you can click on it and you will get right to this code, so you can actually see it in action for yourself, and then you can tinker with it. That way you don't have to start blank, or you can see maybe if you're having issues, you can compare it to it, so you can fix your issues a lot easier. Thanks for watching. Until next time.